Okay, half of my heart is in Havana. 3.2, proving properties of parallel lines. We're going to do more proofs today, but with the parallel lines properties. Okay, so a couple of days ago, you guys learned what alternate interior angles were. Remember, alternate interior angles were angles on the inside, interior, and they alternate. So for example, angle 3 and angle 6 are alternate interior angles. And we also were told that all alternate interior angles are equal, but only if we have parallel lines. All right, and today we're going to prove it. All right, so to prove it, we cannot use alternate interior angles. We can use everything else. So here's how we start off. We always start off with a given. Line M and N are parallel. All right, so as soon as we know that M and N are parallel, because that's what is given, then you can use all the other properties except alternate interior angles. All right, so remember all the other properties that you learned the other day. All right, so in this problem, we're trying to prove that 4 is equal to 5. So this angle is equal to that angle. We need to prove it. Why is 4 equal to 5? All right. The first thing I know that angle 1 is equal to angle 4. How do I know that angle 1 is equal to angle 4? They have a very specific vocabulary word. Hopefully you remember. 1 and 4 are called vertical angles. All right. Now we have angle 1 is equal to angle 5. 1 and 5 are equal. They also have a very specific vocabulary term. Why the relationship between angle 1 and angle 5. Do you guys remember it? They're called corresponding angles. All right. So hopefully you kind of see what I'm leading towards. If you look here, if angle 1 is equal to angle 4 and angle 1 is also equal to angle 5, then we can kind of take away the middle thing, the thing they have in common, and conclude that angle 4 is equal to angle 5. And I hope you guys remember what that was called when you eliminate the middle thing they have in common. It is the transitive property. All right, so that's how a proof works, is you're going to use what you know to prove something. All right, and again, that is not the only way to do that. There's a lot of different ways to show angle 4 is equal to angle 5. But this is the most straightforward way. If you come up with a different way, definitely show me, and then I'll see if it works or not. Okay? Let's try another one, the alternate exterior angles theorem. We're going to try to prove that angle 2 is equal to angle 7. All right, I told you that they were equal a couple of lessons ago, but now we have to show why they're equal. All right, so again, we start off with the same thing. Always start off with the given. So you rewrite exactly what the given says. Notice the given says line M and N are parallel. So now that we know that these two lines are parallel, we can use all of the rules that I gave you a couple of days ago, except for alternate exterior angles, because that's what we're trying to prove. Okay, so let's see, how can we work it out so that we eventually end up with angle 2 is equal to angle 7. Here's my first step, and again, it doesn't have to be your first step, but I see that angle 2 is equal to angle 3, what's their relationship? They're vertical angles. And then I notice that 3 is equal to angle 7. What's their relationship? Corresponding angles. And then here we have this thing where 2 is equal to 3 and 7 is equal to 3. So if we kind of take away the middle thing they have in common, we can say that angle 2 is equal to angle 7 because of the transitive property. So this is kind of like the last proof we did. That's how they'll be going. Here is the last one for the day. We are trying to show that angle 4 and angle 6 are supplementary. Remember, supplementary means they add up to 180. Okay, so let's see how I'm going to do that. Again, we always start off with the given. The line M and N are parallel. The reason is it is given. Okay, so now that they're parallel, we can use all the other rules except for consecutive interior angles rule. All right, let's see. How am I going to start this? It turns out that I think angle 4 and angle 3 are supplementary. So 4 and 3 are supplementary because they make a straight line. They make a straight line. All straight lines are supplementary. And then angle 3 is equal to angle 6. Let me erase that to make it look a little bit more cleaner. Angle 3 is equal to angle 6. How do I know that? 3 and 6 have a very special relationship. They are alternate interior angles. All right? Well, let's see. If angle 4 and angle 3 are supplementary, and then 3 is equal to 6, what if I substitute the 6 in place of 3? And so I have angle 4 and angle 6 are supplementary. And what did I do? I kind of substituted in angle 6 for angle 3. So substitution property. And that's it. We got to what we're trying to prove. All right, I know these proofs are a little bit weird. There's lots of ways to do it. They're not easy. And how did I even get those steps? Because there's so many steps that you can go by. But the more we practice this, the more you'll kind of get used to using the next step and then finding the reason. Okay? Today's homework is a little different. It is a worksheet. So go ahead, you can print out the worksheet or you can copy the worksheet. It is your choice, but go ahead and try it yourself.